Pathogen 360. Let me show you and we'll talk about how this this project works. So let me boot it up, and I will also load the necessary local model for inferencing. I'm just gonna increase it to 2048. Member settings, bump it up, and now we can trigger the application itself. So this is what Pathogen 360 looks like. This is predominantly created from a vaccines perspective. The end user is supposed to be somebody from a business development team or a marketeer or a researcher. The whole idea is that this application can help users understand the unmet needs specific to vaccines, which pathogens are rising in severity, which ones are not, and so on. Whenever a user logs into the application, he or she gets a full 106 pathogen library fully created. They can go ahead and filter these by the type, whether it's a viral, whether it's a bacterial, fungal, parasitic, and so on. And all the viral families are also there. You could also search a library. For example, if I want to do an mpox, I get that. At the moment you look at the pathogen, you get the latest year for which the data is included in the synthesis, how much information is going in. So there are around 100 Pubmed articles, around 62 trials, and 10 CDC alerts that are there. The moment I click on it, it shows the knowledge nucleus that the AI researcher has access to. So you can go ahead and you can look at what are the types of therapies which are in there, what vaccine development is happening, what are the recent surveillance alerts, etc. You could look at all the underlying Pubmed documents that have gone in. Each of these documents is a live document, so you can go ahead and look and download the actual document itself. Same goes for the clinical trials. What clinical trials are specifically going on within mpox, what's their status, whether they're recruiting, not recruiting, which phases they are in. Any epidemiology data that's coming from WHO, if it's not found, it doesn't show anything. Any CDC alerts related that may have been issued around mpox, so all of that information is there. So this is what the knowledge base looks like. Again, this is another bacteria, Acintobacter baumannii. You can see all the pipeline status, the disease burden, safety efficacy signals, key gaps, strategic priorities, and some very summarized takeaways, right? The good thing is that all of this is downloadable as PDF. So the moment I go over here, it would allow me to download this entire report as a PDF itself. So I can print it, I can save it, I can take it with me as I'm doing the research. So all of this is good for individual pathogens, but then the amazing thing is I have the access to an AI research agent. Here it's a simple Google-like interface. I can ask any questions, and every conversation that I have is recorded. So there are a couple of questions that I can ask. For example, I can say summarize the clinical trials happening for a virus. Again, it would go ahead and it would say here is the condensed pipeline status for all the clinical trials. Here are some of the key takeaways, which candidates are showing greater efficacy and safety profiles, which ones have cleared human testing, etc., etc. Everything is has a proper citations. What are the bigger gaps that exist specific to vaccine development in this area? What are the investment gaps and potential, and so on, right? Now, as a mechanism to ensure we know exactly what the system is doing, you also have the ability to have a diagnostic flow, which means that every step that from the moment the user typed a question to the moment the answer came, you get everything over here. So in this case, I said summarize the clinical trials. It first did a cold start for loading all the pathogens. It resolved that this is for the chikungunya virus with a certain confidence score. Then it did a route selection. The route selection basically says, is it for a single pathogen, multiple pathogen at a family level, all across? and then accordingly it's going to take the route, it's going to get the data, and then it's going to do the final inference and submit it. And you can also see how much time it took in each case. This is running on local LLM on my machine, so the times are slightly higher. Now this is an example where I gave it a question of across pathogens, which bacterial pathogens are the most unmet needs. Again, it's going to go ahead and provide the entire summary of this, and in this case it said Acinetobacter and Burkholderia pseudomeli. I think these are the bacteria that seems like have the most unmet need. Again, from a diagnostic flow perspective, we get everything. Again, we can see that in this case the LLM made the routing to general instead of specific pathogen, because this was for across pathogens and not necessarily one single pathogen, right? I could do the same thing for a single pathogen, but ask it to summarize research. So for example, if I had a specific question on efficacy, now in this case I have not signified is it for clinical trials, is it coming from Pubmed or wherever, but I have asked it the keyword efficacy, and for mRNA vaccines for SARS-CoV-2, which is COVID. So in this case, it's going to go ahead and look for these across the knowledge base, across Pubmed, across clinical trials, and bring about all of the information that exists. Again, all the citations are there, and we get the complete flow. So this is a very useful tool. You could ask for anything, get the answers, everything is saved, and you can keep on adding to it. It looks at a context right now, so all the context is preserved. And then the last piece is the admin interface, which is where you ingest all the data. Currently, we allow ingestion from Pubmed, from clinical trials, from WHO, CDC alerts. I can go, if there's a pathogen that's not in the database, I can type the name. I can define for how many years of data I want to ingest for that pathogen. I can even do custom ranges over here, and the level of detail. So in Pubmed, you could do full and half and abstract. So if you do abstract, it becomes a little bit quicker. And then what's the ingestion depth? How many documents you want to ingest? You could do 20, 50, 100, 500, all, and so on. Once you do that, all the information is ingested and it needs to be synthesized. Synthesis is creating the knowledge nucleus that we saw in the earlier pages. And once we have synthesized, from time to time, if we want to go ahead and update the information, which is sync clinical trials or sync health surveillance and so on, we could do that. Everything is listed over here for all of the information. So you can see that 100 documents are synthesized. In this case, I had synthesized all the abstract, how many clinical trials were pulled for each of them, how many alerts or so on are captured. And again, you can trigger a resynthesis in case some information is updated. There's also a operational mechanism, so I can go ahead and I can see every run that I did. In this case, I had done a synthesis run. It took quite a bit of time, but it did manage to complete all the pathogens for the synthesis, and so on. So this is essentially what the Pathogen 360 application is. This can be expanded to include any data source. For example, ProMed. If somebody has a ProMed subscription, you can get real-time alerts on any outbreaks that happen for any of the diseases and the pathogens. I think that's a great source to be brought in. We can even expand that WHO epidemiological data with the GHOPI APIs as well. And any data source that we know, we can add in, synthesize it, make it part of the knowledge nucleus, and do that. So this is what the application looks like. In terms of the way it works, I think you can see that a user sort of comes into the front end. It's based on Next.js, and there are three distinct solution components. There is an intelligence layer, there's a core logic, and then there's the data persistence. The intelligence layer, there is an API based routing. So the first thing, the moment the user asks a question, there's an intent routing that happens. Nobody has to write the exact name of the pathogen. They can just say, instead of chikungunya virus, they can just say chikun. It's gonna, with certain degree of confidence, resolve it to a pathogen name. And then it's also gonna go ahead and check against a semantic cache if the exact same question was asked, and if there was no necessary update to the answer or to the knowledge nucleus, it might sort of just go ahead and answer it straight from the cache itself. In case there are some changes, it can also introduce a RAG. If it doesn't exist in the semantic cache, it's going to go to the RAG runner, get the information from both the Postgres and the PG vector, and pick that up. When we do the synthesis of all the documents, it does a temporal fidelity summarizer. What that basically means is that for 2 years worth of data, it's going to go ahead and analyze all the full documents, but then for the rest of the years, it's going to take the abstracts and it's just going to keep on adding it to the themes which is there instead of going through it. So that's basically what we call the temporal fidelity and the recursive compression of information that happens, and then all of this information is again stored within the PostgreSQL database with the PG vector for embeddings and all the chunks which happen. We also use Prisma ORM for managing the database information between the application and the actual database. So that's what essentially the architecture is. All right. I hope this is useful. In another video, I will definitely share more about how I went about building this. But for now, I am using Gemma 3.4b model for real-time inferencing, and I built it using a combination of anti-gravity and Opencode. All right, thank you.